Thank you very much, Ingrid, and the whole committee who put together this wonderful program. It's an honor to kick it off and talk about what I believe is a very challenging topic. It's understanding our own mind and your brilliant minds working within the Human Brain Project on understanding brain and brain function. For me, this is 8 o'clock in the morning. You have this virtual background, which is for me not virtual. It's what I see right now out of my window from Canada, where I'm currently setting up a joint international research unit on the study of consciousness. You're all very welcome to come and visit us. It's wonderful here in Quebec, or in our home lab in Europe, Belgium, where there's a wonderful team of brilliant minds within the Giga Consciousness Research Unit, where it's all about trying to reduce our ignorance about thoughts, perceptions, emotions, and that using all possible technologies, brain scans, and the like. So for those who are interested, a summary of all those brilliant people and labs, you see them there at the Giga Consciousness Research Unit. It's in the Neurology of Consciousness scientific book, co-edited with Olivia Gaussery and Giulio Tononi from medicine. You might know him from integrated information theory on the study of consciousness. But today, it's about your own mind and how you can basically learn to have some controls on thoughts, perceptions, emotions, and to deal with stress. I know most of you are PhD students or early in your scientific career, and it can be a challenge to deal with those sometimes stressful events within the lab, and also, of course, within your personal life and how you find the right balance. So there is not a scientific, but popular book, the No-Nonsense Meditation book, Scientist's Guide to the Power of Meditation, which will be kind of the basis of today's talk. But before we go into that, I would like to use the opportunity to kind of quickly review what the lab is doing. It's mapping human consciousness, both in pathological conditions, that's coma, and chronic disorders of consciousness, related states, but also pharmacological modifications, anesthesia, and giving psychedelics to healthy volunteers while they're in our brain scan machines, or physiological modifications such as dreaming, but also hypnotic state, and since recently meditation, having Buddhist monks in our brain scan. So that's the topic, and then the tools is what you see here in little images. It's of course the core business of the Coma Science Group to translate that knowledge to better clinical care. So there you see our working environment at the University Hospital in Liège, Belgium, a patient severely brain injured after trauma who has this EEG brain-computer interface, and we're trying by all possible means to look for non-motor signs of consciousness and even make it into communication. We would do the same thing with MRI, structural MRI. You see there a diffusion image of these thousands of billions of brain connections. Functional MRI, you see these yellow blobs. You, of course, know from the fMRI resting and activation paradigms. And then there's positron emission tomography with FDG, that stands for fluorodeoxyglucose, because the brain uses an enormous amount of energy, and we can visualize that. So your brain should look all active, red, yellow. There's a lot of synaptic activity there, a lot of glucose uptake, and patients who are unconscious, this image where everything kind of is blue, a massive global reduction. And we now have means, of course, to see the dynamics of that when patients recover or fail to recover. And then, of course, we have high density EEG, can couple it to TMS, transcranial magnetic stimulation. And basically all those techniques over the past, 25 years now, permitted us to identify not one, but two conscious awareness networks. That's what you see on the drawing. It's external or sensory perceptual awareness, which seems to be critically dependent on that frontotemporal network that you see in red. So it's this global neuronal workspace, front, back of both hemispheres. That is important for you to be aware of your environment, everything you hear and see right now, everything coming through your senses. And then there's another component, which is the little voice in your head talking to yourself, permitting you to anticipate, to reflect upon your own past. This is the internal awareness network overlapping with the default mode network. You see in blue, it's mesiofrontal, anterior cingulate, and then there's the precuneus, which is a critical hub, the most connected area of your gray matter, very metabolically active, and then adjacent posterior cingulate cortex. And of course, the power of your brain is how all these parts are interconnected. The cortical and also thalamocortical dynamical interactions that are represented by these arrows. So that's what we do within the science lab, but that's also what we do as clinicians, translating that for better care. And one example, this is a recent paper from Aurore Thibault, Olivier Gaussery, the co-directors of the Coma Science Group. They had the cover of Annals of Neurology just a couple of months ago, illustrating the added value of these technologies. You see patients after coma who survive. Now we call them unresponsive wakefulness syndrome. Unresponsive wakefulness because they remain without a response to command, but they are awake, eyes wide open. And they used to be called persistent vegetative state. I really think we should avoid that term, not comparing human beings with vegetables. And historically, I think we've underestimated the capacity of the brain to still have some residual activity and hence the capacity of a functioning mind. And that's exactly what's undiscovered, where we show also minimally conscious state patients, very challenging because they do have some signs of consciousness, like they would smile when their loved one is in the room, but that's all you got. And you can't communicate with them by definition. You see there's more EEG high density connectivity illustrated by these threads. The more threads, the more connectivity, and the more red, the more efficient, and then recovery of functional communication and healthy controls. But you also see that there's this category of MCS star. These are patients who look unresponsive, completely unconscious at the bedside, but neuroimaging tells us otherwise. And they're quite frequent. The paper here shows about 2/3 of patients, 67%, which of course is too frequent to just continue clinical business as usual. We need to be more attentive. We need to improve the trajectory of care after traumatic brain injury, after cardiac arrest, brain hemorrhage, and clearly EEG, but also positive emission tomography. That's what you see up here, where again, these patients with at the bedside, no signs of consciousness, show some islands of cortical metabolic activity. And they also, as the study shows, have a better prognosis. And that's then the results of the structural voxel-based morphometry, MRI. T1 analysis. So that's our core business, I would say, trying to understand consciousness and translate that knowledge to better clinical care in severe traumatic brain injury, but now also in concussion. That's one of the reasons I'm also here in Canada, where unfortunately there's a lot of expertise because of American football, because of ice hockey. So we're studying these NHL and other champions with MRI. You see one example here, again, diffusion MRI showing the thousands of billions of brain connections. In this case, in Delphine Persoon, she's Belgian, she's the world champion boxing. And of course, that's very dangerous sport for your brain. And we again need to increase our understanding so that we can take better care of post-concussion syndrome, and that within the existing network, not just of Human Brain Project, but also with FIFA, with the Olympic Committee reform initiative, and it's tremendous to see that collaboration going. So today we're talking about the mind, about consciousness, which clearly is one of science's biggest mysteries. And I think we better stay a bit humble. We could not just pretend we have understood it all. It's currently really a mystery. We have no explanatory theory for your own thoughts, your own perceptions, your own emotions. And I think a fascinating topic and something that deserves, again, more scientific attention are near-death experiences. We have now over 1,700 of people who were close to death and tell us what they actually experienced. While we thought they were fully unconscious, they tell us, well, they had emotions and a sense of peacefulness. They had out-of-body experiences, as you see here, in about 80% of the cases. And studying this, and you have the long list of papers here by the team led by Charlotte Martial. And if you're interested, please send us an email, nde@uliege.be or coma@uliege.be, because I think this is so fascinating, and it's basically covered by Hollywood movies or books where the science behind it is a bit lacking, and maybe that should change. For many, it is considered proof of life after death. As a scientist, I don't think we can make that claim, but clearly we can no longer ignore this very fascinating topic, and I'll be very happy to discuss it with you if you would have any questions. Now, with the team, and this is work by Jitka Annen, very active within the Human Brain Project, we also have the opportunity to study extraordinary minds. This is top athlete Guillaume Néry. You can check him out on Google. He did wonderful TED presentations, and he's the world champion of apnea diving. He went down, he's the only human who survived a dive to 139 meters, free diving. And how do you do that? Knowing that your brain uses so much energy. And in the lab, he came under high density EEG monitoring, under functional MRI monitoring, holding his breath for 7-8 minutes. And that paper was just published, showing he's actually in a meditative state. And the talk of today is to hopefully convince you that you don't need to be a top athlete to be able to well, enjoy the power of your own mind. Another bunch of people we've been studying over the past decades are the astronauts. There's 7 up there in the International Space Station right now. And we have the opportunity, thanks to collaboration with the European Space Agency, to study their brains before they take off and when they come back, and how zero gravity impacts our brain structure and function. Actually, just last week, we had a paper that came out, and you see the image there. It's the tracts that are significantly decreased when they come back from the International Space Station, who some of them, you see Gennady Padalka, the record holder with over 870 days up there. So clearly we need to understand the impact of those extreme conditions when, as humans, we're preparing to take off to Mars. We, of course, down to Earth, also use these technologies and our understanding of the human mind to understand the entrepreneurial mindset. And, you know, in these COVID times, of course, it's very challenging for young people, for students. Father of five, I've seen that myself. It's very, very difficult times, and I think we underestimated the impact of the virus, not just on our bodies, but especially on our mental well-being. And so how do you deal with uncertainty? How do you deal with challenges? Well, entrepreneurs are a very interesting population when it comes to that kind of cognitive flexibility and adaptability. So we've studied a bunch of them. Paper is coming out soon, and this is again a collaborative effort between Belgium and the center here in Canada. And the guy you see there on the MRI scan is the CEO of probably one of Belgium's best chocolate factories, Galère. So the power of the mind is also illustrated when we listen to music. I think we all know how moving that can be. And for us, it was extraordinary to be able to see inside the mind and brain of professionals such as here the director of the Brussels Opera, where you see how music would activate his brain, again looking at a connectivity representation here. But what was more impressive to me was how his own mental imagery, when he was imagining the music, it was really firework. And you see there, he's in silence, but his brain is very, very active and showing very loud activity. So our capacity for mental imagery is extremely powerful, and we can even use that in clinical context. In our hospital in Liège, we have now over 15,000 patients, including myself, who had surgery while being in a hypnotic state. So that means you're just awake on the operating table, the surgeon is doing his thing, but you are absorbed, dissociated. And we've shown and repeatedly published that there's a significant reduction in functional connectivity in the external awareness network I discussed previously, that lateral frontoparietal network. We also work with industrial partners. This is a startup, Unconfort, from Belgium, and they propose immersive virtual reality goggles. So that permits the patient to have access to this hypnotic state while being engaged in this movie and the sounds. Again, we've used neuroimaging to validate these novel techniques. Olivier Gossery recently published the brain activity in cognitive trance. So this is a very challenging subject where I think we can learn from these very primitive ancient traditions. This is a picture taken from a shaman in Mongolia, where Corinne Sombrun, who is French, she wrote wonderful books, and actually there's a movie for those who are interested. It's A Bigger World, Un Monde Plus Grand. They basically came film in our own lab, showing the science behind trance. That's also one of the reasons I'm here in Canada, close to the Native Americans, where that, I think, knowledge can be translated and useful for me as a clinician, where I think my job is not just to prescribe drugs and quick fixes, but maybe empower each of us as a patient to tap into that capacity we all have. And you don't need to be a shaman to be able, and that's what we've been showing with Corinne and the recent paper in clinical neurophysiology. But today, and that's the reason I believe you're here, it's about meditation. And again, you know, from these Buddhist monks and this iconic picture, you remember in Vietnam, this monk putting himself in fire. We can only try to imagine how extremely painful this must be, and he is not moving an inch. Now, this is just an extreme example. We, of course, have very different lives than Buddhist monks, and yet I think they can be inspiring. And that is why I was very happy that I met Mathieu Ricard. You see him here on the picture. He is French, actually a scientist, obtained his PhD in Institut Pasteur, Paris, in molecular biology, and then had some kind of existential crisis, went for a postdoc to India, Nepal, and became very experienced in Buddhism, and is now the translator of the Dalai Lama. But he's also an incredibly patient and collaborative guinea pig. And together we set up a couple of studies, and that's what I use in the book as a basis, as an example of what we do know about meditation and the effects on brain structure and function. And I think it's fair to say I come from, I kind of dramatically changed my vision on meditation. And I remember a journalist shortly after the defense of my PhD thesis on consciousness, that was in 2000, journalist calling me and asking, well, Professor Laureys, what do you think about mindfulness and its usefulness in schools? And so as a scientist, you know, you go to Medline, you check the papers. And at that time, we're here, 2000, and these are the number of scientific peer-reviewed articles every year. In gray, it's those on mindfulness. And I wasn't convinced, and that's what I told them. And since then, you see the two past decades, really there is an explosion in the number of scientific articles. Just last year, there were nearly 1,800 papers, 1 year on the subject. So we can no longer say, as I did 20 years ago, you know, it's a bit fluffy, it's esoteric, I don't believe in it. It's no longer a question of belief, it's just backed up by science. And currently the most studied type of meditation is mindfulness. That's what you see in this graph. It's in the book. And for me, that was a discovery, because I never ever during my studies at medical school and later as training for a neurologist, meditation was hardly ever mentioned. And if it was rather in a negative context. Beware, this is alternative medicine. Keep away from it. And I think that's a pity, because of course it's useful that I know these drugs and how they work on our neurochemistry, and they're really useful. But there is no happy pill against the unbearable lightness of being. We maybe should tap more in our own potential to pay attention to what's happening between our ears in our own mind, to reconnect with our own emotional experiences. How do I feel? And how do you feel? How do we interact? And that's, of course, important for each and every one of us as a human person, how we interact with our partner. Many of us will have kids. It's a challenge, I can tell you. I have 5. How do we, at the workplace, interact with colleagues, with our supervisor, with director, dean? All of that can be very challenging. That's what I see as a neurologist, dealing with patients who come with sleeping problems, with anxiety, with depression, with burnout, with tension headache. And of course, chronic stress is not good for us. It has also been shown by brain imaging. It's basically impacting the volume of your hippocampus, and we need our hippocampus. It's important for memory, amid other things. So as for many people, I had to hit the bottom. I went through a personal crisis in 2012, and can find about that in the book. But that's how I got into yoga, meditation. And then there was this meeting when I gave a TEDx talk in Paris on consciousness, and there was this man, scientist, but also monk, and that's Mathieu Ricard, who gave a talk on meditation and compassion. And we became friends, and he invited me to go for a retreat with him. That was with Mind and Life Europe, a wonderful initiative bringing together neuroscientists and scholars, experts in contemplative practices, founded by the Dalai Lama. And so I enjoyed that retreat very, very much. And I invited, my turn, Mathieu to come to the lab. And we put him in all machines. That's what you see here, going into the MRI scanner of the University Hospital in Liège in 2015. And we could see with our own eyes how meditation, and in his case, of course, it's useful to start with the extremes. Mathieu Ricard, as a Buddhist monk, has more than 60,000 hours of meditation behind him. And so his brain, when we do volumetry of his T1 weighted MRI, measuring the overall volume of his neuronal mass for something who's over 70, his brain, neurologically speaking, is 10, 15 years younger. And more specifically, this is again an image from the book. In the critical areas you see there colored, which you will recognize as the hippocampus in red. Next to it is the anterior cingulate, the anterior insula in blue, the left prefrontal cortex. So all areas that are important within the activity of meditation. That's basically gymnastics of the brain, because meditation is all about orienting your attention. And so no wonder that the anterior cingulate cortex, which is like critical in attention orientation, just is increased in volume, as is the prefrontal area and the connections with the amygdala, because meditation is more than just better dealing with stress or focusing attention or developing your creativity. It's also an invitation to reflect upon your own emotional well-being and the well-being of others, and empathy and compassion. And so the emotional network shows structural changes. And that, of course, is visible with diffusion tensor imaging. You see here Mathieu, you maybe recognize his face, and we look inside now his white matter, these thousands of billions of axons where the colors, as you know, reflect the orientation of the fibers. For example, the red is left to right. And so you recognize the corpus callosum connecting the left and the right hemisphere, which is repeatedly shown. You see again, one review in Nature Reviews Neuroscience from now a couple of years ago. Meditation impacts the gray matter, the white matter, and for example, the denseness of the intercallosal, interhemispheric structural connectivity. And of course, a more connected brain is a more efficient brain. So that's what neuroplasticity, of course, is all about. That's what we've been studying so intensely in the damaged brain, but it's fascinating for us as a team to now look at the power of neuroplasticity in more preventive medical contexts. And that's also what actually is being done now within European networks in patients who are at risk for cognitive decline. Because your brain, as said, uses a lot of energy, and we can visualize that with positron emission tomography, fluorodeoxyglucose imaging. And you see here Mathieu going into such a PET scan machine, and you see the image of the energy uptake. And when you get older, this metabolic activity decreases. That's just aging. And meditation, it has been shown, you see the paper there in Scientific Reports a couple of years ago, has a measurable positive impact on that metabolic activity. It is even, as said, now proposed within multicentric studies for patients at risk for Alzheimer's. Of course, it's not a vaccine, it's not a cure for this terrible disease. We have no cure, also not pharmacologically speaking, but it is important that we can give a more active role to patients. And meditation, I think, is just one of the very important pillars of our lifestyle, our life hygiene, as important as sleep, as your physical activity, as what you eat, as your social interactions. And so I think it deserves more attention. It is a form of mental training. And we should not see meditation as thinking of nothing. Your brain actually never is flatlining. We've been studying the workings of the mind for the past 25 years now. And the only time you would really see absence of thought, of brain activity, is in brain dead. And meditation is not the aim to go in brain dead. You see here Mathieu with this over 250 electrodes while he's sitting, eyes closed, doing nothing. But your brain can't help it, right? It thinks. Right now in your own mind, you are having thoughts and they jump from one to the other. And so this is in this internal awareness network overlapping with the default mode. You see again here, high density EEG connectivity. The more threads, the more interaction, the more red, the more active. And when he would start to meditate, because it's the baseline recording, when he's meditating, this is what you get. So meditation is not just a decrease of brain activity. On the contrast, it's a very active mental process where he's focusing and controlling the workings of his brain and mind. And of course, I can talk about the topic and give you theoretical knowledge and scientific facts. But meditation is meditating. You know, it's an act. There's no one who can do it for you. It's something you just need to give a try. And I'm not a Zen master. Who am I to give you any teachings on the matter? So I will just shut up and let the expert speak. Louis? So this is my youngest son, Zen Master Louis. This was made in the middle of the first wave when we were in lockdown in Belgium. And it can be quite intense. We all went through it with our own different challenges. But what you see here is Louis just taking a break, just breathing. And that's a very interesting anchor. You know, when times get tough and your mind is just spinning and you can be overwhelmed by emotions, Louis, you can notice that and just do one thing, which is breathing. And focus your attention on the breathing. While doing that, and I think it's just a rediscovery of something that probably as a kid we were better at. If you get distracted, you simply bring back your attention to the breathing. And you see this network of the fMRI connectivity that is impacted. So this is giving you a very effective, it looks simple, but it can be quite a challenge, possibility to, first of all, observe and then impact your, what Mathieu Ricard calls monkey mind. It's these thoughts jumping from one to the other. We all know that it can be sometimes disturbing because we're distracted all the time. And studies show that more than half of the time, our thoughts are elsewhere than with the actual task we're supposed to focus on. And one way to illustrate that, and when I give talks with Mathieu, this is a real live recording when we were on stage in Brussels in front of 4,000 people. And I would just put the simple EEG. You see 3 electrodes. I can't put the 250 set, of course, when we're in such a theater, but this system, it's called a neurosphere, permits me on my smartphone to see what's happening inside the mind of Mathieu when he's on stage sitting, and you see his mind, monkey mind, jumping from one to the other. So you see time on the axis, and then you have the different components of EEG activity. So this is a simplified, I would say, artificially colored representation of the different components. So this is general arousal and focused attention and executive functions. And you see from red to yellow to blue to green, you can visualize how your continuous stream of consciousness, as William James coined it, jumps from one to the other, wild monkey we sometimes have no control of. And then Mathieu would invite the audience to do a meditation exercise. And that's actually what I would like to do right now with each and every one of you. So I would propose we just stop talking about meditation, but have a seat and just do it. Is that okay? So you're probably all behind the screen sitting. And my invitation is that we just sit comfortably. Also, the people in the organizing committee, please join us. We will do a couple of conscious breaths and focus our attention to one thing, which is the breathing. Probably thoughts will pop up. That's the exercise, to notice them and bring the attention back to the anchor of your respiration. Okay, so we can anchor both feet on the ground, sit comfortably with a straight back. You can lay your hands on your thighs, you can close your eyes, and we would just inhale through the nose, exhale through the mouth. Doing great here. So in, and we're gonna exhale a little bit longer. Wonderful. You can put your hand on your belly, and when you inhale, you see your belly expand. And you exhale, your belly contracts. Can you feel that? Doing great. We can count in 1. Bit longer out. Doing great. 2. Two more. last one. You can open the eyes, reconnect here and now where you are. So this simple exercise gives us a means to impact our autonomous nervous system. You know, you have the orthosympathetic, fight or flight, ready for action, but also active when, you know, we're stressed by whatever, making our heart go faster, blood pressure going up, stress hormones being released. But you also have the parasympathetic, of course, and every time you exhale, you would automatically activate parasympathetic nervous system, which makes your heart go slower. Blood pressure, and you can all check this with smartwatches and wearables, blood pressure going down. If you measure your cortisol or adrenaline, they would go down. So you just feel this. And if you measure what's going on in the mind, this is what you would see. See, the black line is when Mathieu Ricard starts meditating, and this is on stage. It's really not ideal lab circumstances, but you see a radical change. When the first was the monkey mind and colors going from one to the other all over the place, you here see more stability. And then he's again into whatever activity. So that's what is going on in your mind when you do focused attention to breathing meditation. And that's something you can basically do anywhere, anytime. And meditation, I think, is a bit like sport, right? It's probably important that we move and we have sedentary lives, spend a lot of time behind screens. Actually, there was a study in the JAMA recently that showed that young people spend, you know, how many hours a day behind screens? 4 hours a day. And in COVID, it doubled to 8 hours a day. So that's 8 hours a day in the pandemic. Young people were behind screens, and that is without screen time related to school activities. So it's really a lot. And so then it's important that we, you know, have physical activity, and you can do that choosing different types of sport. Some like to go running or swimming or biking or playing tennis, whatever, going skiing. Meditation for me is just like sport. It is taking care of your not physical well-being, but mental well-being. And you can do that by breathing meditation, but you can do yoga, you can do transcendental meditation where you would repeat a mantra in your head, you can do a body scan, there's mindfulness-based stress reduction programs. There are so many ways to do this, and depending on what you do, you would see different brain networks activating, and that's illustrated here. Mathieu now on stage is doing another type of meditation, which is compassion training. That's his favorite. You know, he wrote wonderful books on empathy, compassion, but also caring for others, including animals. And he's a very strong activist for animal well-being. And so when you train compassion, you would see a different type of EEG signature, basically, as illustrated on the slide here. But meditation can also happen when you go for a walk. And again, with these challenging times, we've seen how important it is to reconnect with nature, to be able to go out, to have a walk in the park, if you can, in the woods. That's the huge chance I have to be here in the middle of the woods, to see the water right now out of my window. That impacts us. It invites for contemplation. And again, children are incredible little Zen masters. And this is, again, my youngest son, Louis, when he's going for a walk with me in the woods here, well, very often I would be on my phone, you know, calling the hospital or whatever, or I would be texting. And even if I'm not on one or the other screen, my thoughts are elsewhere. And meditation is just an invitation to, you know, do one thing, monotask. When you walk, and you have all your attentional load to this one thing. You can train that. You can just be very attentive to, what do I see now? You know, the leaves, the colors, what do I feel on my skin? The wind, the sun, what do I smell walking in the woods? So that simple exercise of going for a mindful walk would again be a different kind of exercise where you are activating the so-called external awareness network, being very attentive what's coming into your senses. And then the last network, emotional network, it's the one that you train when you're asking really to yourself, how do I feel? It's a question which is, I think, again, a bit neglected, and where my wife, who's a psychologist, she's a mindfulness teacher, going to schools and using these icons. When sometimes it's sunny, but it's not sunny all the time when we talk about our emotional meteo. And sometimes there's clouds and it's storm, it's lightning and raining, and it is an invitation to just observe and let them pass. Because we've been studying the workings of the mind for the past decades. We never ever saw a thought, perception, emotion that was just permanently, immovably there. They come and go. And so emotions were very strong to, you know, when we feel angry, it comes and goes, right? But then we bring it up again. You know, my colleague, what did he say again? Or reviewer two, and it will be, we're very good in bringing it again and again and again. And at one point, it's kind of useless. It just stresses us. It's keeping us from having good restorative sleep, having good interactions, working properly, being with our friends. We're just always bringing it back, and studies show it's more frequent than not negative thoughts and emotions. And so meditation is an invitation to notice that and then let go. Just let it pass. And there's different ways, and they're in the book, how we can, each and every one of us, you don't need to be a Buddhist monk for that, can learn that. And it's a pity maybe we never learned that at school. And again, coming back to our guinea pig, and what we published is documenting this with EGTMS. So, you know, you can hit the brain with transcranial magnetic stimulation. Stereotactically, you see an MRI image, and the star is that part of the gray matter that we would excite with the TMS while simultaneously recording the EEG. This is actually a technique developed by Marcello Massimini, very active partner in Milano within the Human Brain Project. And we will now do that routinely in patients after coma to document the capacity of the brain to have conscious awareness. It's also in line with Giulio Tononi's integrated information theory. And we saw that when you're anesthetized, this what we called perturbational complexity index would go down. In deep sleep, it goes down. It goes up again in dreaming, as the Milano team showed. And here, for the very first time, we saw that in normal waking conditions, Buddhist monks could very actively and in a controlled manner change our complexity measures one way or another. And that's what was published. And that's, I think, a very good illustration of how you can learn to control the workings of your mind and be, well, I think, a better human being, a better scientist. It can help us focus, be more creative, help us to fall asleep when it's a challenge. And it's wonderful to have people like Mathieu Ricard who collaborated not just with our lab, but with many others. Antoine Lutz is one of the pioneers from Lyon in Europe. We see Richard Davidson in medicine, the things we've been talking about, how meditation changes the EEG frequency bands, how it can affect the affective networks, and empathy and compassion training, and also, as we discussed, impact age-associated brain metabolic changes. And again, you don't need to be a Buddhist monk. Studies show that if you and I would start to do 8-week programs, and these are mindfulness-based stress reductions, you would also see visual effects, visible effects, as the ones described with neuroimaging techniques. We even see effects at the level of your genetic material. So this is, again, an image from the book. You have these telomeres. When you get older, they become smaller, and then you're more vulnerable to disease and cancer because they protect, to oversimplify, your DNA. And stress and chronic rumination seems to intensify that process. And meditation gives you a means to positively impact that. And I think it's very interesting, and it's been repeatedly shown. You see there one review paper in Current Opinion in Psychology that also at the level of the chromosomes, we see the measurable effect of meditation. Clinical trials show that the effect can be as big as the effect of antidepressants, anxiolytics, and analgesics. And I think we shouldn't say this is an alternative for drugs. To me, it is just complementary. And I would like to build bridges between what we call classical medicine and alternative medicine. I don't like this term. I think we should empower patients and tap into the power of the mind, and also offer this to kids at school. I think we focus too much on knowledge. And the big challenge now, we have very, very powerful machines, and we talk about artificial intelligence. Maybe it's not a good term, because a machine doesn't really have intelligence. It doesn't feel anything. It doesn't think anything. It has no emotions. It has no ethical values. It also feels no motivation to do things or frustration when things fail. So we need to invest in what makes us different from these supercomputers and robots. And that is our emotional intelligence. That is what we're talking about right now. And that, unfortunately, is not, correct me if I'm wrong, part of our curriculum. And that's a pity. As a neurologist working in intensive care, I see a lot of young people who commit suicide attempts. So it's a challenge. And I think we really need to increase our efforts. And of course, also later, in the elderly, it's very important that we keep an active mind. I had the opportunity to meet the Dalai Lama several times. This is in Strasbourg at a scientific meeting. He has a very, very sharp mind. And again, we have very different lives from these Buddhist monks, but we can learn from them. And when we do that, neuroscience in a nutshell has shown that in the dynamics of the exercise we just did, when we had breathing meditation, we were distracted very probably because one or the other thought or perception came up, activating insula and anterior cingulate cortex. And then we became aware of that distraction, reoriented our awareness to the breathing, activating different areas, prefrontal, posterior-parietal. And then the exercise is to sustain that focus. Mind wandering would again occur, precuneus, mesiofrontal, that default mode network, which is important for mind wandering, which is not a bad thing, but it's interesting to give you tools to at least become aware of the process and give you some control. You can do that with your thoughts. You can do that with your emotions. That is what meditation is about. You see this in, I would say, a more acute situation. Mindfulness, meditation, hypnosis as a state, an act, and we use it as said, not just meditation, but also hypnosis in a clinical context, and then as a trait, which is the long-term practice. And we can start with that. And I would, and that's what I prescribe, recommend mindfulness-based stress reduction 8-week programs, because then you're in good hands and it is backed up by science. So that's my take-home message. Meditation is an invitation to train attentional networks focusing on control of thoughts, perceptions, emotions, backed up by science, different networks involved. That is part of what we do with the Joint International Research Unit of Consciousness here in Canada, back in Europe within Human Brain Project and our partners of the GIGA Consciousness Research Unit in pathological conditions, pharmacological modifications, and then what we just discussed, the power of the mind that I think we can all benefit from. So if you're interested, the book is out there. It's now translated in nearly 10 languages. It's taking up a lot of also my personal time. And the message is, do what you can. You see the cover of the next exercise book. I'm sitting there in lotus or failure, but that's not necessary. It makes pictures that's interesting for journalists and book covers, but you can do the exercise we just did sitting on a chair. You know, take the time for some breathing pause. I do it in my consultation while dealing with families from severe traumatic injury, just between 2 consultations. The most important and challenging for me is to say, oh, now I need it. But I can do it on the train, commuting to work. I can do it when I'm stuck queuing in the supermarket. So that is the message. Do what you can. Don't put the bar too high. And there's many ways to meditate. And you just need to try them out. Like in the sushi restaurant. Taste it, you like it, you take more. If not, you just wait for the next exercise of meditation. There's one final thing I wanted to share with you and then leave time for questions for 15 minutes. Been talking about the books from our teams, but for those who don't know it, there's, I think, a very nice little book by Jeff Schatz. It's called Jeff's View on Science and Scientists. It's worth reading, as is for all young people starting a career in science, a wonderful book by my colleague and friend Stuart Firestein. He's professor at Columbia. And the title of that little book is Ignorance. It's a word I mentioned when I talked about the mystery of consciousness. I think ignorance is a wonderful drive. It's not about what we know, it's about what we don't know. Within the Human Brain Project, it's about the brain, the mind, and how interesting it is to reflect on how little we do understand when it comes to the neural code of thoughts, perceptions, and emotions, and how sometimes we pretend we know in advance how our different experiments will turn out, the so-called hypothesis-based projects. We're very good at writing and the papers, while reality shows, and I really love the message of that little book, Ignorance, how it drives science, where he says, just give me the data and I'll give you the hypothesis. And it's this culture of permitting and cultivating serendipity. Sometimes we're looking for something over there and something completely else, something very different comes up. And that's where really the nice scientific discoveries and the paradigm shift, you know, Nobel Prize winning eureka moments happen. So remain critical. Don't just do what your supervisor or research director tells you to do. Don't take anything for granted. Be a rebel, and challenge the neuroscientific truths of today while taking care of your mind and your loved ones. Thank you so much, and I look forward to your questions.